All right, so I just thought I would go through this review sheet with you just to help you, and you can follow along if you want while I'm doing it. So long division, x squared obviously goes into 3x cubed 3x times. When I multiply that, I get 3x cubed minus 6x. So then when I change the signs, I'm going to have what? Negative x squared plus 2x plus 1. This one's got a little bit of a weird one. It's going to go in negative 1 times. So then I'm going to have negative x squared plus 2. But then when I change those signs, now I get my crazy remainder of 2x minus 1. So this one has a remainder, which then you put over the divisor. So not my favorite question to start off with, but it's good to show that it doesn't always go out even, right? It doesn't always come out even. The next one, let's see, I'm going to say x squared goes into x to the fourth, x squared times. If I multiply, I get x to the fourth minus 2x cubed minus 2x squared. Again, I'm going to change the signs. I really like doing that in a different color. The nice thing is that that all drops out, so I have negative 3x squared plus 6x plus 6. And that looks like it's going to go in negative 3 times. And I believe that I'm home free here, yes. So then when I change these signs, everything's going to drop out. So that one comes out even. When you do synthetic division, you set the opposite of the number aside, which is 2. 1, negative 3, 1, 1, negative 3. Drop the first number down, multiply, add, multiply, add, multiply, add, multiply, add. Yeah. So this does not go in even, it has a remainder. It always goes down by a power, so x to the fourth becomes x cubed minus x squared minus x minus 1, and then the remainder goes over the divisor. People get confused about this one, this negative 1 power. Remember, negative 1 power is just going in the denominator, which is basically saying that it's divisible. Oops, that was a 4. It's divisible by x minus 4, or x minus 4 is the divisor. So we put the 4 aside, 1, 0x squared, 0x, and negative 64. Drop the first number down, multiply, add, multiply, add, multiply, add. It goes in evenly. I end up with x squared plus 4x plus 16. Done and done. Is x minus 3 a factor? Well, we know if it's a factor, it goes in evenly, and goes in evenly means there's no remainder. So that's negative 5, negative 15, negative 17. I can tell right now that it is not a factor because there is a remainder. And I don't even need to know what that remainder is. Difference between a factor and a 0, I always like to use like x squared plus 5x plus 6, let's say. When I factor that, these are the factors, right? These are the factors. When I actually solve it and get negative 3 and negative 2, these are the zeros, or the x-intercepts, or where the graph crosses the x-axis. If we give you a factor for free, like life is kind of good, right? X minus 2 is a factor for free, so we know that that's going to divide in synthetically with a remainder of 0, but we need to go through it, right, so that we get all the numbers right there, and we have x squared plus x minus 2. Now that's going to factor again, so x plus 2, x minus 1. And I always like to include the original factor in to just reinforce that a cubic equation can have 3 factors. If they give you the 0, so now it's x is 1, that comes from the factor x minus 1. So I'm going to divide this in, again, knowing that it goes in evenly, right? Negative 11, I messed up. 1, oh, because hello, 1 times 1 is 1, so that should be 0, which is 0, which is negative 9, which is negative 9. So the leftover factor, x squared minus 9, which of course factors again, x plus 3x minus 3, but this one wanted all the zeros. So you want to make sure that you understand what the question is asking, if it's asking for factors versus asking for zeros. When we state possible rational zeros, that's our P over Q list. That's the numbers that go into the last number divided by the numbers that go into the first number. Since the first coefficient was understood to be 1, the P over Q list is essentially just the P list. Versus here, maybe I'm going to write out the P list, which are the numbers that go into 12, 1, 2, 3, 4, 6, and 12. And then the Q list is the numbers that go into 3, 1, and 3. So this is going to have like a jillion of them, right? Plus or minus 1, this is the P over Q list. Plus or minus 1, 2, 3, 4, 6, 12, because they all go over 1. And then when you put them over 3, 1/3, 2/3. You don't have to say 3/3 again, because that's already 1, which is already in your list. Same thing with 6/3, which is 2, and 12/3, which is 4. So there's the P over Q list. All right, so here we're finding the zeros. When it's already factored for you, easy speasy. You're just solving each one, setting each factor equal to 0. But x squared plus 2 equals 0, I might just write that out and square root both sides. Again, plus or minus I root 2. So reinforcing when you take the square root, that it always has plus or minus. Here with the x to the 5th, I gave a hint of factoring out the x first. And I'm going to change this to a 0 because we're finding the zeros, right? So x and then x to the 4th minus 6x squared plus 8. We had that polynomial on a previous worksheet, and we had it even in a previous chapter, the quadratic-ish chapter, where we can just factor that, right? So if we factor that, here, this is going to be, well, I can actually probably just solve it. X is 0. X squared minus 4 is going to be 2 and negative 2. And x squared minus 2, and I set that equal to 0, square root, I'm going to get plus or minus root 2. So all in all, 5 answers. Now's the first one where we really have to like figure it out, right? So we have this P over Q list, which is just like huge, right? Plus or minus, like 1, 2, 4, 5, 8, 10, 20, right? Right? On and on and on. And, you know, you might be overwhelmed by that, like, how many can we, you know, test? Remember that the answer is always within the first few. And here's the thing, you can peek at the graph. So if you throw this on your calculator, you're going to see that it hits, I'm just making up what the graph might look like, but you'll see that it hits at 4. So you have to show your work, but you can like pick 4, kind of knowing that 4 is going to be the answer. Drop the first number down, multiply, add, multiply, add, multiply, add. And now you're like, okay, I got the answer of 4 comes from the factor x minus 4, but now I have something that doesn't factor, hence my hint. X squared minus 6x plus 10, we got to put that in the quadratic formula. B squared minus 4ac, that's a 10 there, by the way, all over 2a. So this turns out to be, I think, negative 4 underneath there, which is 2i over 2. So the final two zeros are 3 plus or minus I. And you got those from quadratic formula. That doesn't always happen. Like, you know, here's like a normal one. Now here 56, again, is going to have a pretty high P over Q list. 1, 2, 4, 7, 8, 14, 28, 56. But don't get caught up in that. Always look towards the beginning or peek at the graph. And this one, the one that I'm going to do first is x equals 2, comes from the factor x plus 2. I basically know that that one's going to work. 1, negative 1, 34, negative 34, and negative 56. So dropping the first number down is negative 2, negative 3 is 6, is negative 28, and then that cancels it out. So x squared minus 3x minus 28. So x minus 7, x plus 4. So x is 7 or x is negative 4. So again, the cubic equation, 3 answers. So finishing out these on the bottom, now we got a smaller P over Q list for here. The numbers that go into 3, of course, 1 and 3, and then when you put them over the 2, 1/2, 3/2. Again, always starting with the lower numbers, always peeking at the graph, so kind of making that, quote, educated guess where you actually know that this is going to be the answer, right? Dropping the first number down, multiplying, adding, and then you're like, oh yeah, look at that, it works. 2x squared plus 7x plus 3. And now you're like, please factor, I don't want to use quadratic formula. You don't have to, negative 1/2 and negative 3. And again, if you've peeked at the graph, you can see that those are the answers. Here with the 4, the P over Q list would be 1, 2, and 4. And again, putting those over 2, 1/2, and then 2/2 and 3/2 we already know. Again, if you peek at the graph, you'll see that 1 is an answer coming from the factor x minus 1. I can put that in over here with the 2, 3, negative 11, 2, and 4. It's running out of room here. 5, 5, negative 6, negative 6. That gives me, let's see, negative 4 and then 4. Oh, this is a 4th degree one. Okay, so this one, you do have a 4th degree one on your test too. So 2x cubed plus 5x squared minus 6x minus 4. Now that one, I got to do the p over q thing again. Now this one is just a hard one. There is a 4th degree one on the test, but it's not quite as hard as this. This is going to say that it's hard. I'm saying this one's hard because negative 1/2 is the leftover factor here, or the extra 0, 2x plus 1, and then 2x squared plus 4x minus 8. And then that one doesn't factor, it uses quadratic formula, and turns out to be negative 1 plus or minus root 5. Now that's a little tricky. Again, I would use the graph to help you. There is a 4th degree one on the test, but it's not as hard as that one. Moving on. So now you're actually graphing them, and then you can look at your calculator, obviously, to help you. But you should be able to look at that that's factored and say that that has a triple root at 2. 2, 2, and 2. And then it's going to be like this kind of thing. Now, when you look at the y-intercept on your calculator, it's going to be 0, negative 8. You're always going to do the y-intercept as an ordered pair. And then here, min and max, there is no really relative min and max. The maximum is going to be up here at infinity, kind of like the end behavior, and the minimum negative infinity. If that one's on the test, I wouldn't even ask for max and min. I would just ask for y-intercept. Here, if you graph this one on your calculator, I'm going to write these roots as ordered pairs, just because that's how I see them. Negative 1, 0, 1, 0, and 3, 0. So this is going to have a root at negative 1, a root at 1, and a root at 3. Y-intercept, if you do that on the calculator, is 0, 3. So 1, 2, 3. So it's like this kind of thing. But it's actually not the max. If you actually do the second calc, max, left, right, enter, you're going to get these decimals. So negative 0.15 and 3.1 there. Or here it's 2.15 and negative 3.1. So you're just using that literally from the calculator. You always want to write your root like the same number of times of its multiplicity. So when I see this negative 1 repeating 4 times, I'm going to write it 4 times. Similarly, I'm going to write that the 3 repeats twice. And I'm going to remember my rule about bouncing and going through, that these are going to bounce. So this one's going to be kind of like a W, although I think that height of the W goes really high, 0, 9. And then here for the max is like that point up there is a little bit higher, 1.67, comma 8.99 or something. I'm reading that off of the answer key. And then the minimums are actually those 2 points. So the roots are actually the minimums there, like that. How you can tell if it bounces or goes through, well, remember, if it repeats an even number of times, it's going to bounce. And if it repeats an odd number of times, it's going to go through. It's not about the value of the root, it's about how much it repeats. So negative 3 to the 4th, I'm going to call that my root number 1. Doesn't matter which one you call it. It repeats 4 times. 4 is even, so it bounces. Root number 2, it only repeats once, so it's 3. Root number 3 repeats 3 times, so it's through. And root number 4 is a 5, which repeats twice, which is even, so it bounces. So now we're getting into these patterns, right? Looking at the pattern, and I don't even care really like what the graph looks like. Like, you don't even have to graph this on your calculator. What I'm really looking for you to understand is how the power and the sign of the leading coefficient impacts the graph. So if it's an odd power and a positive sign, it goes uphill. That's all you need to know. Odd power, positive sign goes uphill. So this goes towards like infinity and then negative infinity. Odd power, negative sign, down the hill. So this is negative infinity and then infinity. Even power, positive sign is some kind of smiling, right? It basically goes up and up. It's happy. And then even power, negative sign is some kind of Z, W going upside down. Like I said, you don't have to know that in terms of exactly what those graphs look like. I'm just going to have some kind of like questions about the end behavior based on what the leading coefficient and power is. The last thing is, again, writing polynomials that have certain roots. So if you have these 4 or 3 roots, right, those are the factors that comes from. And I always like to add that 0 in. So here, if you FOIL this, what is this? X squared minus 5x plus 6 times x plus 4, distribute, 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 and then clean it all up. And then this one's going to be 14x plus 24. 3i negative 3i. We've done this question so many times. We did it back in quadratics, but people still get it wrong. X squared, outers and inners drop out, minus 9i squared, x squared minus 9i squared, the same thing as positive 9. Here, with the 2 minus I and the 2, this is going to be x minus the quantity 2 plus 3i, x minus the quantity 2 minus 3i. Distribute and regroup, right? Distribute and regroup. So when we distribute and regroup, we get x minus 2 minus 3i and x minus 2 plus 3i. Then it becomes a FOIL question. The inners and outers we know are going to cross out, so you don't even have to do them. X minus 2 times x minus 2, x squared minus 4x plus 4, and then minus 9i squared, same thing as positive 9. 9 plus 4 is 13. Doing another one here. I'm feeling like, okay. Doing another one here, let's see, x minus the quantity 3 minus 2i, and x minus the quantity 3 plus 2i. Again, I'm going to distribute and regroup, so I get x minus 3 plus 2i, and x minus 3 minus 2i. FOIL, but I don't have to worry about the outers and inners. X minus 3 times x minus 3. I'm going to do it up here. X squared minus 6x plus 9, and then minus 4i squared. So x squared minus 6x plus 13, again, equals 0. And don't forget the equals 0, right, because it's an equation. This one here, I purposely chose the same root. So if 2 minus 3i is a root, I automatically know 2 plus 3i is a root, and then I just really need to know that third root. And I said to use the answer from 25 because you've already found the quadratic that has those 2 roots. You already did that work, so you don't need to do that work again. And then we would just do long division, which I don't have room to write here, but if you do long division into there, you get the other root, which is x plus 1, or other factor rather, so the extra 0 is negative 1, and the graph would confirm that. And then here, same thing, x is equal to 3 minus 2i, automatically x is equal to 3 plus 2i, there's 2 leftover roots, but we already did that work up there to show that it's x squared minus 6x minus or plus 13. And if you do long division to divide that in there, you get x squared minus 1, which of course is x minus 1, x plus 1, so 1 and negative 1. And I just, deleted that last page. So this is the review sheet on polynomials functions.